Hey guys, welcome to the next section of the Getting Started with Spring 5 course. And this section we're going to review the ways to access data using Spring Framework. In more details, we will overview what actually Spring provides to access data, the features that are built into the Spring Framework, for example like leveraging the JDBC template. We're also going to review the Spring Data Project's capabilities in terms of accessing data from different storages, like whether it's relational storages or NoSQL storages. So let's start with overviewing the ways to access data in Spring Framework. First of all, we have three probably the most used technologies within Spring Framework, which is JDBC, which is basically the standard that is coming out of the box from the JDK, which allows to access relational storages. But Spring, however, adds some additional capabilities on top by providing the JDBC template, which simplifies a lot the ways the data can be accessed. Then we have more advanced way to work with relational storages, which is the Hibernate. Hibernate is a framework which provides not only the access to the data, but actually the object relational mapping capabilities, which allows us to work with objects in our code and not to be tied with relational nature of the storage. And finally, we have a JPA, which is a Java Persistence API, which is actually the specification or set of APIs that can be implemented by the persistence provider. And Hibernate is one of those persistence providers which implements the Java Persistence API. Along with support of rich set of technologies to access data, Spring also provides some additional value on top of this. And the repository annotation is one of those values. And actually this annotation does two things. First one, it allows us to register automatically classes within the class path to be instantiated and registered as a Spring Beans. So basically it's a stereotype annotation. The second one is actually the classes annotated with this annotation will be provided with capabilities to wrap all thrown exceptions within methods with data access exception in order to generalize exception handling capabilities of the data layer. So here we can see the hierarchy of exceptions that exist within Spring Framework in order to differentiate different exceptions that could be thrown by our applications in the data access layer. On top of each, we have a data access exception, which is extended by different exceptions to cover concrete cases where exceptions can occur. If we are talking about JDBC to access data within Spring Framework, we have three capabilities to do this. First one is by leveraging the JDBC template, which is actually the classic and the lowest level approach. Then we have a name parameter JDBC template, which actually brings a bit more advanced way to work with database by using the name parameters instead of placeholders that are coming from the classic JDBC. Then we have a simple JDBC insert, simple JDBC call, which is actually allows us to provide some kind of lightweight mapping between the object-oriented Java nature and the relational nature of the underneath database. In order to access data in this way, we need to provide the name of the table and some map with keys in this map similar to the names of the columns of our table. Let's take a more deeper look at the JDBC template, which has some additional features like it actually handles the creation and release of resources. Basically, we do not need to manually create a connection and release it because it will be handled by the JDBC template. Then it also creates and executes statements. So basically, we can write not only some select queries or delete queries, we can actually also call the stored procedures within the database. Of course, JDBC template provides the ways to handle exceptions of underneath JDBC layers and transforms them to the more friendly Spring exceptions. Okay, now let's take a look how actually we can access data from our application by leveraging the Spring capabilities. In order to do this, let's go to our source code to the section 8 and let's open build.gradle file. So here we have several additional dependencies. Let's focus on the most relevant to our video. So we have the Spring Boot Starter JDBC dependency, which will actually provide us the ways to access data using JDBC technology. We also have the H2 dependency as a database that we will have in runtime. It's actually the relational database, which will allow us to avoid installation process of some concrete relational storage like MySQL or Postgres, etc. Okay, now let's go to the source code even deeper in src main resources folder, where we have some pretty interesting files. We have the data.sql and schema.sql file. So basically, within Spring Boot, there is a convention that if those files are present in the class path, then they will be used to set up the database. For example, schema.sql file is used to create a schema for our storage. For example, when Spring sees this file, it will execute it, and in our case, it will create a table in our schema that is called stocks with ID, name, and the price. So basically, we will implement not just the API to access data, but actually the controllers and almost fully working application that will be providing some stock information. Then we have a data.sql file, which is actually the SQL file that will populate the created schema. So in our case, we are inserting some records to our stocks table, and all will be done automatically by the Spring framework. Okay, now let's go to the Java code. So in compact Spring 5 package, we have our regular starting class. Then we have stock data aware controller, which will actually provide the API to access stock information from underneath storage. So we have here pretty known annotations like get mapping, request mapping, REST controller, put mapping, so nothing too new. However, we have quite interesting annotation here, which is a qualifier, which actually allows Spring to differentiate different implementations for the single interface. And in our case, we have a stock DAO interface, which provides the contract to access underneath storage. It actually has two methods like find by ID and the save stock. Find by ID finds the stock information by stock ID, and save method provides the implementation to actually add or update data within underneath storage. We also have different implementations, but in this video we will concentrate at stock JDBC implementation, and as we can see, the qualifier annotation again is used here in order to mark that this implementation is actually the JDBC one, and if some injection of interface is used with this qualifier annotation and with same name, then this implementation will be injected. So this is the way how it works, and here we have the JDBC implementation of the data access within Spring framework. So let's try to understand what we have implemented here. So let's take a look at find by ID method, which is actually quite simple. It has single argument, which is actually ID of the stock, which we are looking for, and there is an SQL query which selects ID, name, price from the stocks table for the given ID. And this ID will be passed from the parameter of our method. Then we are creating the request from this query to our database using the JDBC template method query for object. And as we can see, JDBC template is injected to our implementation by the Spring framework. So JDBC template is generic interface and it just executes the given queries. However, it actually provides some additional ways to simplify the developer's life by allowing us not just to retrieving data from result set by IDs or by names, but actually it allows us to add some mapping capabilities, because in this case we have a mapping of result set from the database to the stock class, which is our data transfer object. So this DTO class has ID, name, and the price. And here we're actually also leveraging the Lombok project, which simplifies things in terms of automation of creation, the getters and setters, equals and hash codes, etc. Okay, so as for the pin property row mapper, as we can see, it's a class that is coming from the Spring framework, and it provides a mapping of the result set from the database to the given Java objects, unless the fields of this class are corresponding to the columns from the returned result set from the database. Actually, along with find implementation or read, we have the write, which actually creates a new or updates the existing records in our table. And this is implemented in the save method, where we have transactional orientation, which actually brings the support for transaction for this method. So basically, if something happens here, the transaction will be rolled back. Then we have a SQL query to our database, and we are leveraging the notation from H2 in order to insert the record if it's not exist and update if it's already there. However, please note that for other databases, this notation might not be existing. Okay, then we're also leveraging the update method from the JDBC template, which accepts the query and then the values that will be inserted into our database. And actually within the query, the question marks will be replaced with concrete values which we passed through the API of update method. Now let's try to start our application. Let's go to our start class. Let's start it. Here we go. So our application is about start. Here we can see it is starting. Okay, now let's open our controller in order to understand how actually we can access it. So for sure we would like to try with the get method. Then we have in the get mapping stock and then the ID of the record. For example, let's go with Google, Nasdaq, go. Here we go. Wow, great. As you can see, our application returned the exactly stock that we are actually having in our database. So for Google, we have 975.63, and here we have exactly the same stock information provided by our application. Okay, this works. Now let's try to add some data to our database, and in order to do this we need to switch to the put. Let's copy the response body, because now we need to change it to something else. For example, let's increase the stock, for example 97.78. Here we go. And now let's try to execute. Okay, and now also let's try to get the updated value. Here we go. So this is actually exactly what we saved into our database. So our JDBC based implementation is actually works. And let's open the console. So we do not see any errors. So it actually works as expected.